The second question of Green's theorem is verify Green's theorem in plane for this integral 2xy minus x square dy plus x plus y square dy, where C is the closed curve. This is the closed curve of the region bounded by y equals x square and x equals y square. This question was asked in 2062 Paush Bachelor of Engineering. So first of all, we need to plot the graph. So y equals x square. So this is the parabola and this is also parabola. So y equals x. For every negative and positive value of x, y will be positive. So it will be like here, and whenever x is 0, y is also 0. So it is like this. This is x-axis and this is y-axis, and since there is square in x, so it will be symmetrical about y. And next parabola is y equals x equals y square. For every positive and negative value of y, this is y. So for every positive is this and negative is this. For every positive and negative value of this y, x is always positive, and so this lies in this path, not this path. So when x is 0, y is 0, so it passes through origin. So this will be like this type of parabola. So to find the limit, it is here y equals x square, and from this x equals y square. X equals y square and this square is 4. So it would be y power 4 minus y equals 0, y cube minus y equals 0. So from this y equals 0, and from this y equals 1. So when x is 0, when y is 0, x is also 0, and when y is 1, x is also 1. X is 1. So the point will be 0, 0 and 1, 1. This is 0, 0, this is 1, 1. So this line integral will be from 0 to a and from a to 0. So it should always in anti-clockwise direction. So from 0 to a and from a to o. Along this OA, this is y equals x square. Y equals x square. So that differentiating we get differentiating this with respect to x is dy by dx equals x square with respect to x is 2x. So dy equals 2x dx. Dy equals 2x dx, and x varies from here x is 0 and here x is 1. X varies from 0 to 1. Now this will be changed into 2x y. Y is x square, so 2x times x square is 2x cube minus x square dx plus x plus y square is x. Y is x square and y square will be x square, the whole square is x to the power 4, and dy is 2x dx. So here we have changed all into yoks. Limit is also yoks, this is also yoks, and all is yoks. So now 2x cube minus yoks square and 2x times yoks is 2x square and 2x times yoks 4 is 2x power 5. So it will be 2x square minus yoks square is simply yoks square. So by integrating it would be 2, and integration of yoks cube is yoks 4 divided by that 4 plus yoks, and this is 2. So integration we need to add 1. So 2 plus 1 is 3 and divided by that 3, and finally 2 yoks, that is power 5, so we need to add 1, so it is 6 and divided by that 6, so 3 and 2. So yoks 4 by 2 plus yoks cube by 3 plus yoks to the power 6 by 3, and limit is from 0 to 1. So plugging upper limit, it is 1 by 2 plus 1 by 3 plus 1 by 3, and lower limit all will be 0. So it would be 1 by 3 plus 2 times 1 by 2 plus 2 times 1 by 3. So it is 3 to the 6 and 3 plus 4. So it is 7 by 6. Now along this OA, this is the y square is yoks curve, y square is yoks, and here you can convert this into either yoks either y, this into either yoks either y, and limit also either yoks either y, but you should choose in such a way that it is easier. So if we convert this yoks to y square, then it will be easier because it will have the power term. But if we convert all into yoks term, then what happens is 2 yoks and this y is written under yoks minus yoks square, and the yoks plus y square is yoks, and dy is this, the yoks, dy is yoks by 2y. Here if we convert all into yoks, then here is a rule, square root. So square root is little difficult, little confusion for me, and this divided by 2y is also little annoying for me. So it is recommended to convert all into y, so that there is no uh, square root term and no divided by 2 term. Now it would be 2 yoks is y square times y is y cube minus yoks is y square, so yoks square is y to the power 4, and the yoks differentiating with respect to yoks, it is 2y dy by dx equals 1, so dx would be 2y dy, dx would be 2y dy, 2y dy plus x is y square and y square dy, 2 to the 4, and y cube times y is y to the power 4 minus 2, and y 4 plus 1 is 5 plus y square plus y square, it is 2y square, and in the bracket it is dy, and from 1 to 0, from 1 to 0, 4y4 minus 2y5 plus 2y square dy. Now integrating we get 4 y power 4 plus 1, that is 5, and divided by that 5, minus 2 y power 5 plus 1 is 6 divided by that 6 plus 2 y power 2. So 2 plus 1 is 3 divided by that 3, and from 1 to 0, 1 to 0, it would be 4y5 by 5 minus it would be 3. So y power 6 by 3 plus 2y cube by 3 from 1 to 0. Plugging upper limit, it is 0 in all, and lower limit it will be minus sign and minus 4 by 5 minus minus plus 1 by 3 and plus minus minus 2 by 3. So it would be 4 minus 4 by 5 plus 1 by 3 minus 2 by 3, it is minus 17 by 15. So the total is along OA and AO, it is along OA it is 7 by 6 plus minus 17 by 15. It is 1 by 30. Now we have to calculate this. For this, F1 and F2. F1 is 2xy minus x square, and F2 is x plus y square. X plus y square. So partial differentiation of F1 with respect to y is 2x, and this is there is no y term, so it is 0, and here with respect to x there is no x term, so it will be 0. So partial differentiation of x with respect to x is 1. Now this term would be, this would be 1 minus 2x dx dy, and here the limit of x is from 0 to 1. Here x is 0, here x is 1, so 0 to 1, and we need the limit of y. To draw the limit of y, drawing the small this vertical element, here x varies from this 0 to this 1, and y varies from here, the y is this curve, x square equals y. So the value of y is x square. So, and at here it is y square equals x, so y equals root under x, root under x, and dx dy. First of all, integrating with respect to this variable term, so 0 to 1, x is constant term, so 1 minus 2x, there is no the y term, so it will be constant, so taking 1 minus 2x outside, it would be with respect to y. So integration and this derivative cancels, and remaining is y from this x square to return the x, and it would be upper limit minus lower limit, and this is the constant that is as it is. So, and multiplying these two, it would be this times this is x 1 by 2, and this times this is x square minus my plus minus and 2 times yolks 1 plus 1 by 2 is 3 by 2 plus minus minus plus, so 2 yolks and 2, 1 plus 2 is 3, so it would be I write it here, yolks 1 by 2 plus 1 is 3 by 2 divided by 3 by 2, so it is 2 by 3 minus yolks here it is 2, so 2 plus 1 is 3 divided by that 3 minus 2 and yolks 3 by 2 plus 1 is 5 by 2 divided by 5 by 2, so 2 will be multiplied with 2, so it is 4 and 5 plus 2 yolks are 4 by 4 and this cancels, so remaining is 2 in the denominator, so it is 2 by 3 yolks 3 by 2 minus yolks cubed by 3 minus 4 by 5 yolks 5 by 2 plus yolks 4 by 2, and from 0 to 1. Plugging upper limit, it is 2 by 3 minus 1 by 3 minus 4 by 5 plus 1 by 2, and lower limit, there is all yolks, so all 0. So taking LCM 3, 5 and 2. 3 into 5 into 2 is 30. So here 2 times 30 by 3 is 10 minus 1 times 30 by 3 is 10 minus 4 times 30 by 5 is 6 plus 1 times 30 by 2 is 15. So it is 2 into 10, 20 minus 10 minus 4 into 6, 24 plus 15 by 30. So it is 20 minus 10 is 10, 10 plus 15 is 25 minus 24 is 1. So it is 1 by 30. So this double integral is 1 by 30 and the line integral is also 1 by 30. So Green's theorem is verified.